In this video, I'm going to introduce you to some of the terminology that we use to describe wave motion. In this figure here, I have drawn a situation where someone has thrown a cork onto the surface of a lake. The cork has started to bob up and down on the surface of the lake. Every time the cork goes up, it creates an up bump, which moves away from the position of the cork. Every time the cork goes down, it creates a down bump, which moves away from the position of the cork. So as the cork is bobbing up and down, it creates this wave train of up bumps and down bumps, all moving away from the position of the cork. The highest points on the wave pattern are called the peaks of the wave, and the lowest points on the wave pattern are called the troughs. In this figure, you should imagine that the entire pattern of peaks and troughs is propagating away from the position of the cork at a constant speed. When we talk about wave motion, we generally use the letter C to indicate the wave speed. So you can think of every one of these bumps as moving along the water surface at a speed c. Next, we have the amplitude. The amplitude is the distance from the resting level of the lake up to one of the peaks, and that's going to be the same for every peak. Also, the distance from the resting level down to one of the troughs would also be the amplitude of the wave. Generally, the distance from the resting level up to a peak or the distance from the resting level down to the trough will be the same. So either distance is referred to as the amplitude. So the symbol for amplitude is A. The amplitude refers to the maximum displacement of the wave medium from the resting position due to the passage of the wave. Next, we have the wavelength. The symbol we use for wavelength is the Greek letter lambda. The wavelength of the wave is simply the distance between two neighboring peaks. So if I come into the figure here, this distance right here would be one wavelength. Or for that matter, we could also say that the distance between two neighboring troughs is also one wavelength. To introduce the next quantities, imagine that we have an insect sitting here on top of the water. So as the wave passes through the position of the insect is going up, down, up, down, up, down, up, down, like that. Every time a peak arrives at the position of the insect is up, and every time a trough arrives at the position of the insect is down. So as the peaks and troughs pass through the position of the insect goes up, down, up, down, up, down, like so. With that in mind, I can introduce you to the period of the wave. The symbol we use for the period of the wave is the Greek letter tau. The period of the wave is the time interval between two successive peaks arriving at the same position in the medium. So let's say, for example, that right now the insect is sitting on top of one peak. And let's say that then it takes 0.3 seconds for the next peak to arrive at the position of the insect. We would then say that the period of the wave is 0.3 seconds. Finally, we have the frequency of the wave. The frequency of the wave is the number of peaks per time arriving at a particular location in the medium. So let's say, for example, that every second 4 peaks arrive at the position of the insect. We would then say that the frequency of the wave is 4 cycles per second. Similar to when we studied oscillation, the relation between the frequency and the period is that the frequency is equal to 1 divided by the period. So now I've introduced you to some basic terminology that we can use to describe waves. And in the next video, we're going to begin using this language to develop a deeper understanding of how wave motion works.